guys, so we're going to multiply polynomials. In this case, we have two binomials. We're going to multiply them. Now, quick review. When we multiply variables, we multiply the coefficients, but we add the exponents. Remember that. So in these two examples I have on the board, okay, even though it's not showing, the x's have an exponent of 1. So remember that. Okay. A lot of students forget that. It has an exponent of 1, even though it's not shown. Now we're going to use the box method to multiply both binomials. And to do that, we draw a square. We draw a square. Okay. And then we divide a square into 4 boxes. So that's why it's called the box method. Now, I'm going to place my first binomial on the left side. So I'm going to place the x here and the 3 there, right? And then I'm going to place for the second binomial, I'm going to put the x here and the -6. Now, I could reverse it. I could put the x here and the -6, or and the x and the 3 on top. Doesn't matter which way you want to go, right? As long as you put one binomial right on the left side and the other one on the top side. You can reverse it. It does not matter because multiplying is commutative. So here we go. Now we're going to multiply. My x on the left side. I'm going to multiply this x times this x. So when I multiply them, all right, that's going to give me x squared. Okay. Then I'm going to take this x again. I'm going to multiply it by the -6, and that gives me -6x. All right. Now I'm going to go down and use the 3. I multiply the x on top. I'm going to get 3 times x. That's going to give me 3x. I take 3 and I multiply by the -6, and that gives me -18. Right. Now, once I'm done now, I'm going to add all the terms inside the box. All terms. So that's going to give me x squared minus 6x plus 3x minus 18. Okay? See what I did? All right, all the terms inside the boxes, I'm going to add it together. Now, if you notice, I have like terms. I have a -6 and a positive 3x. I can combine those two terms. If I combine them, remember, I'm going to only add the coefficients. All right, so that's going to give me x squared. If I add a -6 and if I had a -6 and a positive 3, that's going to give me a -3. So that's going to give me -3x minus 18. Okay? And that's the answer. Okay. So we multiply two binomials, x plus 3 and x minus 6, using the box method, and we get x squared minus 3x minus 18. All right. Let's try another one. Let me scroll down, extend my page a little bit more. All right. So here we go. Let's try 2x plus 3 times -4x plus 1. All right. So I'm going to draw my box. Make 4 small boxes. Now I'm going to use the first polynomial. First, the 2x goes on the top left, and the 3 goes on the bottom left. My second polynomial, the negative 4x goes on the top, negative 4x, and the 1 goes to the right. Okay. Now I'm going to multiply. I'm going to take the negative 2x, I'm going to multiply it by the negative 4x. All right, which these two terms. Now remember, I'm going to multiply the coefficients, right? Remember, that's the number in front of x. So negative 2 times negative 4 gives me negative 8. And x is, because I'm multiplying them, I'm going to add the coefficient. So that gives me x squared. All right? Now I'm going to take 2x now, I'm multiplied by 1. That just gives me 2x. All right? Now I'm going to take 3 now. The 3 I'm going to multiply by the negative 4x. 3 times negative 4 is negative 12. That gives me negative 12x. The 3 times the 1, let me erase this little. All right. The 3 times 1 just gives me 3. Now I'm going to add like terms. All right. I'm going to add all the terms inside the boxes. If you notice, right, my like terms are just going to be the negative 12x and the 2x. Right? Those are my two like terms. So if I right mouse, I'm going to get 8x squared, right, plus 2x minus 12x plus 3. Right? And if I combine like terms, I have a positive 2 and a negative 12. If I add those, I get a negative 10. So that gives me 8x squared minus 10x plus 3. All right? So that's my final answer right there. All right, I'm going to do one more, all right, on multiplying binomials. Let me extend my page again. This one is going to be 2x squared, yes, plus 4x. I know you say, come on, Mr. Simpson, that is hard. But it's not. Same principle. 3x squared plus 2x. Right? Just follow the same principle. All right. So let me extend my page one more time and get some more space. All right. Just a little bit. There you go. So I'm going to draw my box, and I'm going to make 4 small boxes. Again, my first polynomial is going to be on the left side. So I'm going to put a 2x squared here and a 4x on the bottom left. On the top, I'm going to have the 3x squared and the 2x on the right. Okay. Same principle. I'm going to multiply the 2x squared by the 3x squared. Okay. So remember, when we multiply variables, we multiply the coefficients and add the exponents. So here we go. So 2 times 3 is going to give me 6x squared times x squared. I'm going to add the exponents. So that gives me x to the 4th. Okay, make sure that's 4. Okay, I go to the, so I'm going to multiply the 2x squared times the 2x. Okay. 2 times 4, that's going to give me 4 x squared times an x. All right, remember the x has a coefficient of 1. Remember that. Let me make a 1 right there. Okay, does have a 1. So x squared times x, that's going to give me x cubed. All right. Now let's go to 4x now. 4x times 3x squared. 4 times 3 is 12. I'm going to multiply the x's. I got an x and an x squared. So that's going to give me x cubed. And then my last two, 4x times 2x. That's going to give me 4 times 2 is 8x squared. All right. So you notice now, my like terms are going to be the ones in this diagonal right here. Those are my like terms. All right, so let's write this out. Let's expand it out. I'm going to have 6x to the fourth plus 4x cubed plus 12x cubed plus 8x squared. All right. Again, my like terms are the 4x cubed and the 12x cubed. I add the coefficients and I'm going to get 6x to the fourth. 4 and 12 is 16. That gives me 16x cubed, right, plus 8x squared. Right? And that's my answer. All right? So that is multiplying binomials or polynomials using the box method. All right, guys?